So now it's evening. We've waited for it to get dark enough to see something in the sky. Earlier we simply had the camera capped, so no light was going into it, so now we can give you a better idea of how it looks with some live imaging. I've switched to the DSI-IV color, and we can show some of the differences between the raw and RGB settings, which I think is critical to show you with the color models especially. That is also applicable to the LPI-G series. So as shown before, I've plugged my camera into the USB port, and now it appears here on the list. Just by clicking on it, I'm going to start to get my live preview. I'm pointing at the moon. The moon is quite a bit out of focus right now. It's a very handy target when it's available in the sky, because if you were looking at a faint star right now, this far out of focus, you simply wouldn't see anything, and you might have some luck by increasing the exposure time just for the sake of getting a faint background star. But when you're this far out of focus, it's really good to choose a bright target. If the moon's not out, choose a really bright name star, you know, Vega or Sirius, something like that. So I can already see it's kind of blown out even though I'm not anywhere near focus. I'm not yet using the auto exposure that I advocated earlier, which I did mention is good on the moon. This is such a thin crescent that it might not provide enough area to show an accurate auto exposure. This is pretty easy to do real time, so I've just kind of decreased the exposure time. No true method to this other than trial and error, but you'll find it's quite intuitive. This is also a good opportunity to show you the zoom. Now on a camera like the DSI-IV, you can see, I mean, there's a lot of resolution here, so we're typically zoomed out. To get better focus, even just to start, I'm going to choose 50%. So this is a handy way of just changing your zoom setting on whether or not you want to see the full frame on your screen or zoom in for more detail. So here's our out of focus crescent moon. I'm going to go ahead and focus this real time. This is what's nice about having the live preview, is that it's almost as if you're looking through an eyepiece when you go to reach focus. It's another thing that makes this step really intuitive. And now I'm close to focus, but you can see it's clearly overexposed. And what we'll do then is further decrease the exposure time. The moon's a nice bright target. And I'm just doing this strictly just eyeballing it, you know. With a deep sky object, it's either visible or it's not. So here's our crescent moon, more or less at the exposure range that we want. I may try to dial in the focus a little more. You can see the seeing tonight is quite turbulent. This is only through 480 millimeters of focal length, and we can see some scintillation here. We've got kind of a cold wind front thing coming in. But anyway, that's another quality of the live preview. So we are essentially focused. Now if I was looking at a star point, I would try to dial it in even more critical than this, but for the sake of just eyeballing it and showing you what we can do real time, we are effectively focused. This auto exposure that I advocated earlier, we can try this, and you can see that it's blown out the moon. Actually, interestingly, in doing so, we get some earth shine that showed up. But we can actually adjust this exposure box so that it's really only looking at the region that we want, and that should actually help us get an accurate exposure time, like so. So it is a useful feature in the auto exposure. This is not going to help you very much for deep sky, and right after this we'll go ahead and slew to a deep sky object. But now that we're focused, whether it's the moon that I've shown you here or a bright named star, we're ready to start going after fainter deep sky objects. If you're using an LPI-G and you're doing planetary imaging, at this point you're ready to start doing that, and you don't have to really worry about going after fainter targets. Now to remove the auto exposure box that we've defined, just uncheck auto exposure. What that's going to do is lock in the exposure time that you have selected. So if you're going now, if I were to go to a fainter target, it would probably be invisible because I have it set to an appropriate exposure for the moon. But like I say, it's a convenient feature to really get you started. Or for planetary imaging, I find it works pretty well for that too. If you just set the ROI on the auto exposure box around the target that you want. Now this time, because I'm using a color camera and not a monochrome camera, the settings that I showed you earlier under format, they're important to take note of. I have RAW or RGB 24. There is an RGB 48 setting. If we go back to bit depth, which was shown previously, as mentioned, we have now either 8 bits or 12 bits as the maximum setting for the DSI-IV. So I'm going to choose 12 bits. In most cases, that's what you're going to want. You can already see how the dynamic range has improved. The exact same exposure time, 8 bits, 12 bits. Of course, showing you on the screen is not giving you a true picture of how much depth there is in the image. It just happens to be a convenient example. So now I'm at 12 bits, which I want to be for the DSI-IV. You can see the temperature has almost reached our target point. Now there's RAW, and now let's choose RGB 48. Now the moon is essentially a monochromatic target, so we don't see any color appear right here. If we were looking at Jupiter or Saturn right now, we would see that color. But since I've done this now at RGB 48, we can now go to a target that contains color, and tonight we will go ahead and select a nice bright nebula to show you that color in real time. Now all the images that you were to save in this mode will be already in color. If you shoot RAW, then your images are going to appear black and white and will require to be converted to color at a later time. Now that we have our live image, it's a good opportunity to show you some of the basic features that were briefly outlined before. I mentioned in File, this is the simplest way. Here's our picture of the moon. This is the simplest way we could save a photo. Just save. It's going to save what's on your screen, at least in the image. And we have our image format types. I had mentioned FITS as the RAW. We can just do TIFF, which is fairly universal. Say moon, and set your save path wherever you would like it to be. Set it here. And that's it. We've saved our first image. Another way to do this is to click Snap. We'll take an individual exposure. It's a still frame. I just click Snap, and here's my shot of the moon. And I can do the same thing. I can simply save this, or I'll say save as. And I have the same, it's essentially doing the same thing. But there's a difference here, because we have a still frame. Our live preview is still going. And our still frame, we can leave this open if we want for reference, if we're framing a target, whether it's planetary or deep sky. Next, if you're doing planetary imaging, including lunar imaging, you're probably going to want to capture a video. And let's go back to our live preview. Our temperature is stable. If I click record, it's going to begin recording a video of what we see right here, and you can see the status in real time. Down here, I've already captured 54 frames, 62 frames. So you can see and look at the file size as it grows. So this is for planetary imaging. It's always something to keep in mind. Your file size is going to go up quite a bit. I'm going to stop record. Now, one way to save hard disk space, since we don't need the full frame, look how small the moon is in relation to the frame. This is where we can go to what's called ROI, region of interest, and we can draw a box around what we want to image and save ourselves a lot of disk space and file sizes just by reducing the frame. And you can even see the resolution there. Now I'm down to 1630 by 1206. I apply subframe, and now there's my moon in a much smaller box. Now let's do it again. I'm actually going to zoom out a little more. Click record. We can see our file size still goes up quite a bit, but not nearly as large as it did when I was doing the full frame. And for planetary imaging, that's really going to be critical, plus you don't need to download the full frame. Now with an LPI-G, you can probably use the full frame, but even then, your planetary target's going to be smaller. With the LPI-G Advanced, you're likely going to want to do that. The planet is still going to be comparatively small to the full frame of the camera. With the DSI-IV here, it's an extreme example because the sensor is quite a bit larger. So now I'm already up to almost 500 frames. I'm still just under 2 gigabytes. I'm going to stop there. And just a reminder where this record path is, I'm going to go back to the preferences window. So it's saving in this path right here. And this is an SER file type, which is compatible with a lot of popular image stacking programs like Registax, which you may use for planetary imaging. You can also do the more universal AVI or MP4 video format. And then it would play just as it would a video camera. So what's nice about this, you can operate the camera as a still frame camera by clicking snap, or operate it as a video camera by clicking record. And record's automatically going to save your image, whereas snap displays the image and gives you the option to save. Now, as previously mentioned, the temperature control, since I am using a DSI-IV color, that should be the first thing that we really tackle, because it'll take a few minutes to stabilize the temperature of the camera. Again, this is not applicable to the LPI-G series, but for the DSI-IV, we should define our cooling. So the DEC is off right now. I have the camera plugged in to its 12 volt power, so I'm going to go ahead and turn it on. Our set point's at 0. And we can easily achieve -5. It's not even going to be very aggressive, but you will quickly start to see the temperature here decrease. And while the temperature is decreasing, it gives us a chance to find and frame the target that we want to photograph. And again, you should wait for this temperature to stabilize before you actually begin taking the photos that you intend to save. So now I've gone ahead and moved the telescope to M42, the Orion Nebula, to show a deep sky target, as well as something that will have color to show that we're using the DSI-IV color. Now this is a bright deep sky target, but you can see there's not a lot visible just yet. This is where you're going to have to play with the exposure time and the gain. Typically with a deep sky target, you want to be at least a second. We're only at 21 milliseconds, so we'll start by increasing the exposure time. Again, most of this is trial and error. I'll go up to a second. You can start to see some of the nebulosity appear. I'm going to extend that even further. We'll take that to 2 seconds, roughly. More nebulosity is appearing. The background looks pretty black, and this is where we can go to the histogram and make adjustments. And again, the histogram is only altering what is displayed. This doesn't actually change the image. This is just so that you can get a better idea of what you're working with, because this is a 12-bit image, so there's more information in the image than you can display on your screen at a given time. So I can manipulate how it looks via the histogram here. You can do that with setting the values on the left side for shadows and the right side for highlights with the mouse by dragging these sliders, or just by setting a value here. And I can also, if I want, I can increase the gain. Like I said, these CMOS cameras are pretty low noise. We can increase the gain and try to get a little bit more signal, go a little bit higher, just to see more of that nebulosity. So you'll change gain, exposure, and work a little bit with the histogram to get an image that looks like something you might be ready for capture. Now, since we're using a deep sky target, we're going to transition from video mode to trigger mode. Video mode, as we've done with imaging the moon and capturing a video, now we want to capture still frames of the Orion Nebula. So our live view is 2.7, 2.8 seconds long. In trigger mode, you've noticed the live view has frozen. Now we're going to take stills. I can take, just to see what we get, a single 5-second image and just click single. You can see the status here is it is about to download when it reaches 5 seconds. Now there's 5 seconds of the Orion Nebula. Now let's say we like this exposure time. This is where now you can sequence your images. In trigger mode, you can set the number of frames that you want to capture. Let's say we want to capture 10 frames. Go to Options. We want to save to disk. And I put in M42. We've got the Orion Nebula. This is where you can define your own naming convention and set the save path. It's going to save this as the FITS file format that I had previously mentioned. This is like your raw file format. Now, these images, FITS, will be in color because I'm shooting RGB 48. Again, if I shoot raw, it's going to be a raw unconverted color image. So let's shoot RGB 48. If you were to take a quick image and you wanted to just export it immediately, you could do one of these other major file formats, but it will not retain all the information that was originally captured by the camera. So it's recommended that you keep this on FITS. Okay, and now to start the sequence, we'll click Sequence. Now it's going to take 10 5-second images and save them to our hard disk. And you can use those later to export and stack and process for your final image. Alright, now let's show you a very useful feature in SkyCapture, and that is the Live Stack feature. This is really great for a number of reasons. Live Stack will integrate the frames that you capture in real time and stack them and improve the signal to noise. It's immensely useful if you're trying to get an image that you're displaying live, let's say at an outreach event or a star party, or you just want to be able to capture an image quickly with minimal processing. This will do some of that processing on board for you. So I've gone to the live stack in our sidebar, align frames, meaning it's actually going to register on the star points, because right now our polar alignment is not perfect, or you may have drift or periodic error or something. It's going to stack on the star points. And we'll say number of frames, we'll say 5. This is the number of frames that stacks before displaying. And you can leave these at the default. There are different ways of integrating the images, average or additive in this case. We want to choose Deep Sky for type because that is going to register on the star points. Now click Enable. You can see the live stack is beginning. Now watch what happens to the image. You start to get a stronger signal to noise. And it's going to stack the image and get more and more image data, and you can export this. And right now you can see there's some background noise. Again, this is just the histogram setting. I have it very aggressively stretched, so we can adjust that as you might do in post-processing. And then when it starts to continue to stack, and there we go. You're going to now get the equivalent of a longer exposure image, but it's stacking the image in real time, and you can get more extended details in the nebulosity. And this is just immensely useful for live astronomy, outreach events, or like I say, doing minimal processing. So do explore that. Check out the Live Stack feature. This is applicable to all of the cameras that are compatible, as mentioned, the LPI-G series and the DSI-IV series. You can do this on deep sky or planetary targets. It's not meant to be a replacement for post-image processing, but it can be a very quick way of obtaining a very nice image with minimal processing. We've covered the essential tools in SkyCapture, and there's a lot more to explore as you continue to use the software. Also, keep an eye out for updates, as we've already posted several with various improvements. Thank you very much.